You can see the screen. You watch the playlist on kinematic problems. Your mic is off.
Sir?
Yeah. So let's do relative motion today.
Your voice is too low.
Okay. You can hear me now? You're using your same device, no?
It's
Okay. Right. So just try this problem. You can see this question, right?
yes, sir.
Yeah, just try this one. The question is clear.
Yes, sir.
Your mic is off. So we can solve this question in a normal way and also using relative velocity concept. Okay, so if you used to solve the question normally, you have to say displacement of A plus displacement of B equal to how much? Okay, I'll give the answer. So this is A, which is traveling a distance, and this is B, which is traveling a distance. So one way to solve it is displacement. Both of them will meet somewhere at time t here, because this is moving at higher speed, so you have traveled a larger distance. So this distance is 30 into t, and this distance will be 20 into t. That should be equal to 200. From this, I'll get the time. So from this, I'll get t as 200 divided by 50. So 4 hours it will meet. Okay, so this is using the normal without using the relative velocity concept. So suppose I will use the relative velocity concept. So so you can either do with respect to A or with respect to B. Everybody hear me?
Yes, sir.
Okay, so
Relative.
if I have to say with respect to B, I'll choose my frame of reference here. Okay, so with respect to this frame, velocity of A with respect to B, I have to find out. So it's a 1D problem. So I can velocity of A is 30. I take this duration as positive. Okay, so velocity of A is 30, and this is minus, right? So minus 20. So VAB is VA minus VB. Okay, and VB is minus 20. So it will be 50 kilometers per hour. So, and the distance, so with respect to this frame, so this car should have traveled this entire distance of 200 kilometers. So the time taken for that is 200 divided by the velocity of E in this frame by 50. So it's 4 hours. Is that clear?
Yes, sir.
Because when the thing is starting, with respect to this frame shown here, the distance of A is 200 kilometers. So as the time progresses, this thing has come to this location of B. So it's as if the A has traveled a distance of 200 kilometers in this reference frame. And in this reference frame, velocity of B is 0. Velocity of A is velocity of A minus velocity of B, that is 30 minus 20. With the direction of positive is towards right. So relative velocity of A is 50. So the time taken is 200. So normal method which you understood, right?
No, the relative velocity only I used.
This is a normal method without using relative velocity concept. Then this distance traveled by A is 30 into t, and the distance traveled by B is 20 into t, because they are meeting at the same time. That should turn out to be 200. Okay, this is in with respect to a frame attached to the ground. Okay, in relative velocity concept, I'm using the frame attached to B. Okay, in that reference frame, the distance traveled by A is 200, while B is at rest, and the velocity of A with respect to B is 30 minus 20, 50. Clear?
Yes, sir.
Okay, similarly, I can take a frame attached to this one. Okay, in that case, the distance traveled by B will be 200, and velocity of B with respect to A will be 20 minus 30. Okay, if I take this one as positive, or if you want to stick to this one as positive, the distance traveled by B will be minus 200, and the velocity of B with respect to A will be minus 20 minus 30. So it will be minus 50. So minus 200 divided by minus 50, it's again 4 kilometers. Sorry, 4 hours. Is it clear?
Yes, sir.
Okay, so this is just 1D problem. So just for introducing, I'm just using that one. So now let's move to 2D. So 2D means motion in a plane. So there will be two coordinates. Okay, this is a plane in which the two bodies A and B are present. So at any given time, the position of A will be RA, say, and this will be RB, and it will be moving in some arbitrary direction. But everything is in the plane of paper because we are not considering 3D motion, it's just a plane motion. Okay, so here velocity with respect to B means I'm attaching a frame to B, right? So with respect to this frame, velocity of B is 0, but velocity of A is velocity of A minus velocity of B. Is this clear?
Yes, sir.
With respect to B, so the frame has to be attached to B. Now this is now it will become interesting. So a person is moving due east 6 meter per second, and then feels wind blowing towards south, speed 6 meter per second. Find actual velocity of wind blow. Okay, if person doubles his velocity, find relative velocity of wind with respect to man. So try this one. We'll draw a figure first. So north is usually upward direction.
Yes, sir.
And this is east. So a person moves at a speed of, so the person is moving in this direction, 6 meter per second. Okay, what this is a thing you have to understand. What is mean by fields?
With respect to him.
So feel means he will feel with respect to himself. So this is according to the frame attached to him. So wind blowing towards south. So what this means as a statement is velocity of wind with respect to man. Okay, that is 6 meter per second south. Okay, let y-axis being the north and x-axis in the right. Is that clear?
Yes, sir.
Okay, so we have to find the actual, and this is velocity of man with respect to what?
Ground.
Yeah. So this thing is by definition it's velocity of wind minus velocity of man, and this is 6 is I cap, right?
Yes, sir.
Okay. So velocity of wind is minus 6 J cap plus 6 I cap. Okay, so I cap is in this direction and then minus J cap is in this direction. So the velocity of wind is like this. Actual velocity of wind with respect to the ground. So, and this angle is how much? What will be that angle? 45 degrees, right? Because both x component and y component are same. 6, 6. Is it clear?
Yes, sir.
Okay. And the magnitude you can see is square root of 6 square plus 6 square. Okay, that's what he is given. Velocity of wind is minus 6 J cap. That's what you have got. Right, and the direction is southwest. Southeast means it's in between south and east. Right?
Yes, sir.
Okay. Now we're saying if the person doubles his velocity, okay, instead of 6, you have to put 12. In the second case, VM is 12 I cap. Okay. Then find the relative velocity of wind with respect to man. So this is the velocity of wind that you have found in the previous one. minus 6 I cap minus 6 j cap minus velocity of minus 12 I cap. So minus 6 I cap minus 6 j cap. So minus I cap means this one, and then minus j cap is this one. So reciprocal will be west, southwest.
Yes, sir.
Southwest. This is clear?
Yes, sir.
Okay, southwest is exactly 45 degrees. It's in between south and west. Okay, so this is a Rainman problem. So here, by looking at the figure, what can you say about the man? He's at rest, no?
Yes, sir.
Okay, so the rain is falling vertically downwards. Why is it falling vertically downwards?
There's no wind now.
There is no wind and it's falling because of gravity.
Yes, sir.
Okay, just gravity there is no wind. So in this case, the person, he has kept an umbrella like this. Okay, now when he starts walking, again there is no wind. When he starts walking, what is happening?
He feels like that rainwater used to fall at an angle.
Yeah, so this is with respect to the frame attached to him, which is moving. But with respect to the frame attached to the ground, okay, the rain is still vertically downwards only. Okay,
Yes, sir.
with respect to the frame. So to understand this one, say, let me identify this vertical line. Say these green drops. Okay, there are sort of raindrops falling in this particular line. At this time instant, the green drop, according to him, it's here, no, on front of him. Okay, after some time, the person will come here, but the green drop has hit him. Okay, so initially he sees green drop in front of him, but after it has come to him. That means the green drop is traveling in this direction. What is the noise? Is it clear?
Once again.
Okay, should I repeat?
Yes, sir.
Okay, the person is standing here. Okay, this line I'm represented by green drops of water. Okay, let me just assume this water is colored green. Okay, at this time instant he will see the green drop in front of him, right?
Yes, sir.
So after some time, this man has come here. Who is walking? Okay, so this green drop which was here at this height, at this location, when it has come here, it will have reached him and hit him. Okay, so
Yes,
the
sir.
drop was initially in front of him, after it has come to him. So that means the drop is traveling in this direction, according to him. Yes? See, something which is in front of him, if it comes and touches him, that means it's moving towards him, right?
Yes, sir.
Okay, but with respect to the ground frame, it's actually going vertically downwards. But initially, this drop was here, but after some time, it has come and hit him. Okay, that's because he has moved here. So it's as if in his frame, it is moving in this direction.
Yes, sir.
Okay, so that's why it's looking like this. So mathematically, we can write velocity of rain with respect to man as velocity of rain minus velocity of man. Okay, and velocity of rain is in j cap direction, right? Or we can say minus j cap if you put upward direction as positive. And velocity of man is I cap. Okay, so it's minus I cap minus j cap. So minus I cap is in this direction and minus j cap is in this direction. So the resultant will be in this direction. Is it clear?
Yes, sir.
Okay. Okay. This question, try this one. Man at rest observes rain falling vertically. He walks 4 kilometers. Okay, now he started walking at a speed. He holds his umbrella at an angle of 53 degrees with the vertical. So to find the velocity of the raindrop. Can you try this problem?
I will try, sir.
See, velocity of man is given, right?
Yes, sir.
It's how much?
4 kilometers per hour.
And what about direction? Let me assume it's moving in this is ground, right? So let me assume this is x-axis. So this will be in I cap direction. Okay, and this angle is 53 degrees, right? So what does that mean? The direction I can represent by cap vector, velocity of rain with respect to man. The direction of this is 53 degrees, right? With vertical.
Yes.
So it is like this. This angle is how much?
53
53.
degrees.
Okay. So velocity of man is towards right. Velocity of rain with respect to man is this way. Okay. So what is this third side then? Velocity of man minus velocity of rain, right? So this should be the velocity of rain should be this way.
Minus velocity of man.
So direction of velocity of rain should be this way because this one is velocity of rain minus velocity of man. If you go in this direction,
Yes, sir.
so from here to here we can go in two directions. This is VRM, that is velocity of rain minus velocity of man. So this triangle is correct, no?
Yes, sir.
So the only thing is
So,
this angle is how much?
53 degrees.
Yeah. So find the velocity of raindrops. So we have to find this one. Okay. So this is I cap. Okay. So this is 53. So this is 4. And this angle is 53. Okay. So this angle is 37. No.
Yes,
Okay.
sir.
Now there is another information. The radius falling vertically. Okay. So the correct picture will be like this. Is that clear?
One.
Okay, so the angle is 90 degrees. This angle is 90. Okay, so 37 means this angle is 53. So property of, 3, 4, 5 triangle, right?
What's up?
This is 3. This is 4. This is 4 and this is 5. So you have a right angle triangle with sides as 3, 4 hypotenuse will be 5. This angle will be how much? And what about this angle? This angle is 90. 3, 4, 5 from a right angle triangle. This is a standard triangle. So this angle is shorter side, no? So this is 37 degrees. And this is 53 degrees.
Yes, sir.
Okay, so 4 corresponds to 4. So this will correspond to 3 kilometers per hour.
So velocity of rain 3, yeah. By
See, velocity of man is 4 kilometers per hour, no? It's given in the question.
I'm asking whether the velocity of rain is 3 or not.
Your voice is not clear.
Minus 3 j cap, sir. And
Okay, yeah, that you can fix. Yeah, it is downwards. So direction is minus j cap. Yeah, velocity of rain is downwards, but the magnitude is 3 kilometers per hour. Okay, right, it's vertically downwards. You have not put j cap on top. Okay.
Yes, sir.
Okay, this one, 2 particles, A and B, projected from ground simultaneously. So picture is shown. One is at an angle theta, another one is vertically up. Directions, okay, velocity is given. kilometers per hour and 10 kilometers per hour. They collide at 0.5 seconds. Find out the angle theta and distance x. Okay, so the thing is, this thing will move in a parabolic motion like this. So if the motion is like this, then there is no collision. Because this thing will go just vertically up and come down. Okay, so this projectile motion should be something like this. Okay, so only when there is a chance of colliding. So you have to find. So this we can solve normally and also by relative motion concept. So if you have to solve the relative motion concept, you have to fix the frame to something. So you will fix the frame to A or B.
Which one will be easier for you?
B will be easier because B has got only y component motion. A will have both x and y. So you choose a reference frame attached to B. Okay, so with respect to B, what is the acceleration of A with respect to B?
Acceleration.
Yeah, there's it's on the earth, no? So there will be gravity force. So because of gravity, there will be acceleration. So acceleration of A with respect to B is how much?
0.
0, because both of them have same acceleration in the minus y direction. Okay, so and the thing is, if they collide, then ACB equal to 0, not every time while colliding, not at other times.
I don't understand the terms.
No, when A and B collide, in the first problem also, in the bus, when both of them meet, the displacement of E with respect to B is 0, no?
Okay, yes, sir. At that moment.
The bus will meet here. So when they are meeting, the displacement of E with respect to B is 0. So similarly, when these two collide, the displacement of A with respect to B will be 0. Okay, so displacement of so we know displacement of A in x direction. So both x and y component of the motion should be 0. So this thing means both XAB at that particular time of collision is 0 and YAB at the collision time is 0. So XAB is UAB into T. Let it collide at time T1. So UAB is how much?
20.
It's 20 cos theta minus 0 into time. So similarly, YAB is 0. So YAB is YA is how much? This guy also, okay. Both of them will be YAB is there is no acceleration, no, relatively. So it's only UAB in the y direction. How much is UAB in y direction? 20 sine theta minus 10. By U may I mean at the initial time. Okay, there is 20 sine theta minus 10.
Okay.
Okay, so and ACB y is this thing into T. So this also is equal to 0. What am I doing? All right. QT plus there is no acceleration, no. So 20 sine theta minus. Okay, I think this thing will give me theta as 30 degrees. Correlate after 0.5 seconds. So I'm not using the information at all. Theta is 30, that is correct. Okay. He's asking somehow find out angle theta and the distance x. Okay. So theta is 30 degrees and the distance x is this thing into time in which it's colliding. So 0.5. So it's 20 into root 3 by 2 and the colliding time is 0.5 seconds. So 10. So 5 root 3. Okay, this is okay. This is actually relative x, no. Okay, okay, no. So about the time. Okay, if they are colliding, then it's actually
X into the time we can find in the distance.
okay. So x is the distance covered by this projectile A in this time 1 second. So that is u cos theta into. So u is so it's just SA at
20.
so x is AC at 1 second, at t equal to 1 second. Okay, so there is u component 20 cos 30. Okay, this is the same expression only.
5 root 3, sir.
Is this clear?
Into 1 by 2. Half second.
Hold on. U cos theta, that is 20 into the time. So it's
1 by 2, sir. You have written 1 second.
What is the mistake?
0.5 seconds. 1 by 2.
Okay, okay. So 5 root 3 meters. So Got it now? So this thing is going vertically up and down. So when this thing is colliding, so it will collide at this distance only. So the distance charged by SA in that time of 0.5 seconds is the distance x. Is it clear? Okay, the important thing is this one. The relative acceleration is 0. That will make it easy to get. This one. So is equal to ut plus half it is given this acceleration, but since there is no relative acceleration, this is just velocity into the time. Okay.
Yes.
Right. This one, two particles are projected from two towers simultaneously, as shown in the figure. Okay, I think you can do this, right? I'll leave it to you. Okay, riverboat problem. Just now we have finished rainman problem, right? So I don't. Okay, maybe we have to solve one more problem that. Okay, so similarly, there is a river and there is a man. So the river in general will be flowing with some velocity at VR. Okay, and the man, he will have the capability to swim with some particular speed. He will be spinning at this speed V is with respect to the river. Okay, so if the person has got a capacity to swim at a speed of say 2 meters per second, that speed when he's swimming in river, that will be with respect to the river.
Okay.
Okay, and suppose he is trying to swim in the opposite direction, then the velocity of the man will be actually V minus VR. Okay, with respect to the ground. Okay, so when he is moving along the direction of river with this capacity, with respect to the ground, he'll be moving at a higher speed, which will the contribution of the river will add to this swimmer's capability. But if the swimmer's direction is opposite, then with respect to the ground, the river effect will reduce the velocity of this man by this much. Actually, the direction of this thing is towards right. So according to the ground, the swimmer is actually moving towards right. But inside the river, his direction of swimming is towards left. But since the velocity of river is much higher than this velocity of man, the effective is moving swimming towards right. Is it clear?
Okay.
Okay, this is still a 1D problem because both these things are in the same direction. But in general, the river will be flowing in this direction, but the man, with respect to ground, will be in some direction, and with respect to the river, okay, it will be in this direction. So this is the relative motion. So man with respect to, so it's velocity of man minus velocity of river. This is velocity of man, and this vector is minus velocity of river. That will be the relative velocity. Is it clear? The triangle is clear.
Yes,
So
sir.
velocity of man and minus velocity of river will add to give velocity of man with respect to river. Okay. So for the shortest path is measured from which frame attached to the earth, the river bank, or frame attached to the river, which frame will measure the distance traveled by the man.
In the bank.
Yeah, see, because this frame is moving, so if you measure distance with respect to a frame that's moving, it will not give a correct measurement, because suppose the distance between these 2 points is say 5 meters with respect to a frame attached to this frame. Suppose I'm sitting in a car and try to measure the distance. It depends on how I measure the distance. Suppose I'm just measuring by instantaneously, it's fine. But suppose I'm measuring the distance by using okay, let me come back. Okay, so it should be measured with respect to the frame or fixed to the ground, river bank. So with respect to the river bank, the velocity of the man should be in this direction. For the distance started by the man should be short. Okay,
Yes,
and
sir.
this velocity is velocity of man with respect to the bank, and velocity of the river is towards right. So the relative velocity should be in this direction. This triangle is
No,
clear.
sir. That VA the only relative velocity, sir.
Vm is velocity of the man with respect to the ground.
Ah.
Okay, so with respect to the ground, he should travel in the shortest path. So he should travel 90 degrees. Okay, and velocity of river is in some direction towards right. So the relative velocity, so with respect to the river, he is traveling in this direction. The velocity of man with respect to his velocity of man minus velocity of river. Is it clear? So velocity of man minus velocity of river. Okay, that should be this relative velocity.
Yes, sir.
So velocity of man with respect to river will be known. That is the Schumer's capability. This will be known, and velocity of river is also known. So from this triangle is known because this is 90 degrees. So we can find, and when this thing has traveled this much distance, so the triangle will be like this. So this is point A, this is point B. So okay, for the distribution to be known, we should travel in this direction. Maybe we can find theta, and let this let this time taken be t. So this distance is velocity of man into t, and this is velocity of river into t. And this is relative velocity of man with respect to river into t. Okay, so tan theta will be time taken is d by b. Okay, b is known. Velocity of man, yeah, velocity of man with respect to river is the Schumer's capability, so that will be usually known. So the time taken is the distance d with the distance between the banks divided by this component of velocity, that is v cos theta. Okay, and v in terms of v cos theta. Yes, so VR is basically time is actually distance to the velocity of man.
Okay.
Velocity of man is hypotenuse square minus this square.
Yes, sir.
So this is the formula. So the important thing is the shortest path is measured from the frame attached to the bank. But for getting the minimum time, it's easier to measure it with respect to the river, because time is going to be same with both the frames. The clock, it's not going to change whether the frame is moving or it's attached to the ground. If you take a frame attached to the bank and another frame attached to the river, the clock in both the frames will be moving at the same rate. It's not going to change. But the distance measurement will change. So since the clock timing is going to be same, so it's easier to measure this thing. So with respect to this frame attached to this river, so to get the minimum time, so the velocity of the man with respect to river should be in this direction, and this is the relative velocity because it's with respect to this frame. Okay, so to understand this thing from this ground frame, the time taken is the distance traveled by the man length of AC divided by the velocity of the man with respect to ground. Okay, suppose you choose, you think this AC should be AB, and the velocity of man in this direction would not be. So here there are two variables. One is the length of AC can change depending on theta, and velocity of man will also change with respect to theta. The thing that is fixed is velocity of man with respect to river is fixed. This is swimmer's capability. Okay, if a swimmer can swim at a speed of 5 meters per second, so when it is swimming in the river, that 5 meters per second will be the velocity of man with respect to river. That is the thing that's fixed based on the swimmer's capability. So here Vm is variable, and also the length of AC is variable depending on where the sea is located. Okay, so here, but in the case of frame attached to this river, the time taken will be this distance d divided by, so d is fixed. Okay, denominator is fixed. So, and say d1 is this distance AC. So whenever d1 is minimum, the time will be minimum, and minimum d1 is d. I'm taking this distance as d1, AC as d1. The distance AC is d1. Okay, and minimum d1 is d. Okay, so it's easier to calculate the minimum time in the frame attached to the river. And V is the relative velocity, that's swimmer's capability. So minimum time is decided by the swimmer's capability. Okay, but with respect to ground, the swimmer is traveling in this path.
Okay.
With respect to the ground, the swimmer is actually traveling in this path. So the swimmer is not, from the path is, when the point is standing, he's not exactly reaching the opposite point, but he's just drifting by this much. Okay, so this drift is, we can find out from the triangle.
We are in 15.
Yes. With the triangle from the ground. This is velocity of man with respect to river into the time. This thing is velocity of man into time. This is velocity of river into time. So this triangle is clear. And this distance is d. Okay, this v is actually velocity of river. Okay, so no, v is velocity of man with respect to river. So to find the drift, okay, velocity of river is known, and velocity, the time taken to cross, that we can find by d divided by velocity of man with respect to river. Velocity of man with respect to river is known because it's the capability of the swimmer, and d is known. From that, t can be known. Is it clear? Velocity of man with respect to the swimmer's capability, that will be known, and d is the distance between the banks, that also should be known. From that, we can know the time taken for the man to cross this bank. Once t is known, velocity of river is known, so we can find velocity of river into time. So that is drift is known. Okay, that's what's written here. BC is the time into the velocity of river. Okay, try this problem. So you're understanding the question?
Yes, sir.
So what is downstream?
The river
Moving along the direction of the river. Okay, that will be easier. Upstream is moving in the direction opposite to the river flow.
yes, sir.
So try this problem. So 2 points, A, B. So in the first case, velocity of, okay, we have to go in the frame attached to the river bank. Whenever distance calculation is there, it's you have to go to the river bank frame. So we have to find the velocity of man, the exact value.
What?
So velocity of man with respect to river, downstream both are in the same direction, right? So velocity of man minus velocity of river. So the time t1, this is distance divided by sorry, velocity of man. So yeah, from this we get velocity of man as velocity of man with respect to river plus velocity of river. Velocity of river is fixed and velocity of man with respect to river is fixed. This is swimmer's capability. Okay, so distance is so velocity of man with respect to river plus velocity of river t1. And what is t2? T divided by
BB plus VR.
velocity of the river is fixed. Velocity of man with respect to river. Okay, so it will be minus velocity of river with respect to the ground is only same, but velocity of man with respect to the man can change the direction in which he wants to swim. That is the only freedom he has. Okay, the second case is changing his direction opposite to that of the river. So velocity of man with respect to the river is opposite to the river.
T1 plus by T1 minus T2 into VR. Answer.
No, this expression is correct.
No, I have written some other expression like BBR.
No, your voice is not clear.
I use a different version. Different method.
No, you got the answer.
Different.
So,
But T1 plus T2 by T1 minus T2 into VR.
no,
That's all. No.
the answer is this one.
So they ask the velocity of the boat in still water, sir.
What will be the time taken to cover
Okay.
in still water? So when the water is still, the time taken to cover, that is T3, that will be the distance divided by velocity of man. And the velocity of man will be the velocity of man. Okay, this is swimmer's capability. It is same as velocity of man with respect to river. So we have to find BMR from these two.
Sir, VM one no, sir. In still water, velocity of
Yeah,
river
still
will
water. In still water, see VMR is the swimmer's capability, right? That's not the thing. That's the thing that's not going to change, and that is equal to VM when VR is 0.
be.
It's VM only, but it's same as a swimmer's capability, which is invariant. So velocity of man with respect to swimmer, I can find from this one. So if I invert this thing, I can subtract how to get that one. So it's d by t1. So VMR plus VR is d by t1, and then minus VMR plus VR is d by t2. So if we subtract these two, I'll get 2 VMR equal to d by t1 minus d by t2. So, and then d by VMR is 2 divided by d by VMR is t2 plus t1. So what is the mistake? In the second case, the time taken is
Sir, 2 T1 T2 by T1 plus T2.
no, this expression seems to be wrong. T2 d divided by the velocity of whichever is dominant. Okay, he has to travel from A to B. So velocity of river should be more than velocity of man with respect to river. Otherwise, he won't be able to travel from A to B. Yes. So this one should be plus.
Sir, answer 2 T1 T2 by T1 plus T2.
So this one is plus and this one is minus. So the important thing is the velocity of man, the velocity of river should be dominant. See, when the swimmer is trying to swim upstream, okay, he will never be able to reach B unless the velocity of river is dominant. Got it? Starting from here, he can move to B when the velocity of man with respect to river and velocity of river in the same direction. But the man is traveling this opposite direction, he'll be able to reach B only when the velocity of river is dominant. It's much more. Okay.
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 I got the answer.
Yeah, yeah. 2 T1 T2 by T1 plus T2. Got it?
Yes, sir.
So this is the mistake I made. So the distance traveled the velocity, effective velocity towards right will be
Yes, sir.
velocity of
Effective
river,
velocity
uh, velocity of man with respect to river is fixed, and velocity of river is more. So it's velocity of river Okay. Okay, to try this one, this is NEET 2019.
Okay.
Speed of swimmer in still water is 20 meters per second. Speed of river water is 10 meters per second. And it's flowing due east. He's standing on south bank. And wishes to cross the river. Along shortest path. The angle at which he should take his strokes. So you will choose which frame? Frame attached to the river bank or a river?
So,
You have to choose either frame attached to the river or frame attached to the river bank. Okay. So which one will choose? Which frame you will choose?
river bank.
Yeah, because it's path. When you want to measure the path length or the distance, you have to choose the frame attached to the river bank. When you want to measure time, shortest time or something, you have to choose the reference frame attached to the river. Okay, because time is not going to change, and it's easier to take the frame attached to the river. But here it's a path, so you have to choose frame attached to the river bank. So solve this problem.
30 degrees. Sir.
So option 1.
Option
Yes.
1.
Yeah. So that playlist, did you see the problems in that playlist?
Sorry, what's this?
No, I sent you a playlist, no? Kinematic problems.
Sorry, sir, I didn't get.
In WhatsApp message, I send you a playlist.
Ah, yes, sir.
So did you try to solve those problems?
Yes, sir. Yes.
So is there any difficult problem in that?
No, sir, I didn't watch it. First video only I saw it. Today night I will do that.
Okay.
This night.
So this relative motion thing is clear now.
Yes, sir.
Okay.
But there will be more difficult problems here, sir.
Okay, you try more problems. The problem which you are not getting, you just send me the snap. So this is NEET 2019. So it wasn't
Yes, sir.
difficult. So the thing is, see here in the case of a river problem, there are not too many complications because river is always going to flow from one end to another end, east to west or something, one direction. The only thing is the direction of the swimmer, and the important thing is the velocity of the swimmer with respect to the river will be constant. That is his capability. The only freedom the swimmer has is the direction of his swimming. He can swim in the direction he wants to swim.
Yes, sir. And then umbrella and man problem is more difficult.
Yeah. So this is the velocity of river will always be in this direction or it can be opposite. Let's stick to this one only. So the velocity of man with respect to river is also fixed. Okay. So the only thing is the direction in which the swimmer swims. It can be here this way or this way or this way. Okay. With respect to the river itself. Okay. So if he has to travel this thing in the shortest path, so with respect to the river, he has to travel in this direction. Shortest path, no? Yes. And shortest time. Sorry. Shortest path he will, with respect to river, he will be traveling in this direction. So that with respect to ground, it will be this one, the shortest path. For shortest time with respect to the frame attached to the river, it will be this path. So with respect to the ground, it will be in this direction. Okay, the problem with this, the complication that can come with this umbrella problem is, what is the complication that can come? So this is the simplest case. The velocity of wind is 0. The man is not moving. Okay, so first complication is the man is moving now. Another complication is there will be wind. Okay, so there are two complications here. So, but the basic idea is same. Okay, one more thing I want to. Why is this guy holding this umbrella in this vertical direction? The umbrella is in this orientation, right? So it's not like this. He's not holding the umbrella like this. Why is that so?
Because it is like that rainwater is up and downwards only, right?
The person is at rest only. Okay, so he's holding the umbrella vertically up, but he can also hold his umbrella like this, right? Why is he not holding like this? See, if it is this orange one, then the area which is this rain is getting blocked is this much, right?
Yes, sir.
Okay, if it is a purple one, the area it is blocking is little bit less.
Oh, okay.
Okay, so it's same like a rectangle or any area. If you look normally, it's like a maximum area is facing the thing. But if you rotate this rectangle to this orientation, okay, then the area that's facing in this plane of paper is less, no?
Yes, sir.
Okay, so this umbrella, if you look from the top, will be like a circle. If I tilt it, it will become ellipse and it becomes smaller and smaller. So if I hold this umbrella like this, the area it's blocking the rain is very, very small. Okay, so same reason when the guy is walking, so with respect to this man, the rain is traveling in this direction. Okay, so his umbrella should be in the same direction so that the maximum area is blocking the rain. Okay.
Yes, sir.
Okay, so when the wind is there, velocity of rain will change. If wind is not there, velocity of rain is vertically downwards.
Yes, sir.
Okay, when the wind is there, include the effect of wind in the rain with respect to ground itself. So it will change to something else. New value of velocity of rain, which won't be vertical, it will be in some direction. Okay, so this velocity. So now the velocity of man is velocity of rain with respect to man. Okay, so maybe I'll solve problems in which there is wind. Okay, next time. So basic idea is clear. I hope so.
Yes, sir.
You can try more problems. And in the case of projectile motion, the relative advantage of relative is it's a uniform velocity motion. So S will become just u into t, half at square time the term will go for relative motion. Okay.
Yes, sir.
So I also have a sheet. Just a minute.
So the problems I sent to your WhatsApp.
Okay, that also is there, no? Actually, those are simple problems only. So let me just do a few of them. Oh, so this one, right? So this is not, can you do it now or it's still not clear? The particle is from vertically upwards, its velocity, half a 10. So the maximum height at 10. So you have to draw the figure.
Okay.
It's thrown vertically upwards, right? So you go up, become 0, and then come down, right? So the velocity at half the height. So at this half height, at displacement at h equal to 2, it's 10 meters per second. Okay, then the maximum height. So you have to find h. Okay, so how will you do this one? See, for this part of the motion, displacement is known, no? How much is the displacement from here to here?
Half.
H by 2. Okay, and the final velocity is 0.
Yes, sir.
So you can use this formula. I'm using Vt because V is 0. Okay, so S is h by 2 half. Acceleration is how much? Minus g, right?
Minus g, yes, sir.
And t is t I have to find out. No, so instead of, so t is unknown, right? So
V square equal to 2.
you can use that. V square equal to u square plus 2as. V is 0. U is 10 square minus 2g h by 2. So what is the value of h?
10 meters.
So why you could not solve the problem? That's because you didn't draw this figure. First thing is you have to draw a figure. Only then the understanding of the problem will become easier. Okay.
So if I get the history, I will continue to do that later. But
so what is the correct option?
C.
You have the answers, no?
Okay.
Okay, you have to check. I'll just mark it here, but you have to check. I don't have the answer. Okay, this is also a simple one. A stone falls free from west and total distance covered in the last second. And the motion equals the distance covered in the first 3 seconds. So first thing you have to draw the figure.
First 2 second distance will be 9 essentially.
So okay, he's dropping from a height. Please don't fall. Okay. So in first 3 seconds, so first 3 seconds means t equal to 3 seconds, right? If I take this as 0, first second is 0 to 1, second second is 0, 1 to 2, third second is 2 to 3. So t equal to 3 seconds, and the distance traveled in the last 1 second. So let it touch the ground at t and t minus 1 seconds. Okay. Okay, so this is the same. So distance traveled in 3 seconds is ut plus half at square. So half g t square is
5
t square, and this distance is ut. Okay, u is 0. So half g t square minus t1 square. Is this clear? This distance is this much. It's actually
No.
Huh?
Okay.
This distance is actually this distance minus this distance.
Yes, sir.
So for both of them, u is 0. So only half g t square terms will come. So this distance is half g t square, and this distance is half g t minus 1 square. So t square will cancel. So it will become half g minus 2t. So it will become 2t -1. So half g will cancel. So t is 9 plus 1, 10. So t is 5 seconds. So I don't have the answer. You have to check. Is it clear?
Yes, sir. Do you want me to check now?
Yeah, if you have the answer, you check it so that we know it's correct.
1 minute, sir. Question number
40.
40. B. Yes, sir.
B is correct.
41.
No?
Yes, sir.
First one is 44 is 10. C.
44. Yes, sir. C only.
Okay. And how are you revising? See, one way to revise is the same problem which I taught you. You try on your own, looking at the solution. Okay. And then you have to take short notes. Short note means the concepts which are not clear to your important points. You just make a short notes of it. Okay.
Okay.
So how are you revising?
Sir, writing by doing problem solving, sir.
No, see, the thing is, uh, class notes I have only in JNT format. Okay, so I have this. If I give you this file, you don't have your laptop is still not working. No,
Yes, sir.
when will it fix?
But I noted in the point important things, like which I don't know previously. Those things I will notify you.
Okay, if you have a laptop and if you can open this file, you can just open this and look at the notes. You can revise. Otherwise, you have to look at the video. That will take more time because if you don't revise, you will not remember. Okay, this one is simple. Velocity time graph. So that's the basic formula, right? Average is V dt divided by what?
Yes, sir.
Is this clear?
Yes, sir. Yes, sir.
Okay, and VDT is area under the curve.
Yes, sir.
So that is
Two times
half into basis
base
basis t, no? So half into t into u divided by t. So it's u by 2.
half will be cancelled, no, sir. Two times that area. Two triangles are
No,
there.
no, no, no. I'm taking this full triangle. I'm taking this full base.
Okay.
Okay, and then base will cancel with this dt. So check the answer. This is question number 15 or what?
B, sir. Yes, sir. Option B, right?
B, no?
Yes, sir.
Okay, so this is the formula for average. This is general formula even for AC current. If you want to find the average of the time varying current, it's integral I dt divided by the total time interval.
Yes, sir.
Okay, ball is rolling from top of a stair, height of. Okay, this is a bit complicated. Okay, the displacement of a body is this one. Oh, this is very simple. X is known, no? So stopping means what?
Velocity should be 0.
Right. So just take dx by dt and equate it to 0. So dx by dt will be a linear equation, no? X is quadratic. So dx by dt will be linear. So from this you will get the time. Okay.
I didn't get the right answer, sir.
What answer you got? dx by dt is
9 by 2.
minus 4 by 3t plus 6. So this thing should be 0. So 4 by 3t is 6. So that is 3 into 3 by 2. So 4.5.
It is not in the option.
Okay, the displacement of the body is this one. How much time required to stop? Okay. T equal to 0.
They are given option B, sir. I don't know why.
Okay, leave it. So this is the idea. Velocity should be 0. Okay, this is 4.5 seconds, right? So another 4.5 seconds would have come to this place. And, okay, leave it. A particle is in motion, so that at moment t, the displacement of the particle is expressed by the equation. So very simple. D square x by dt square, you have to differentiate this thing twice. This,
But I got different answers, sir.
this is okay, 22?
I got different answers, sir.
Okay. So you have to find dx square acceleration, no? So 2x dx by dt equal to 2t,
So I
right?
use it like root of 1 plus
No,
x
no,
square.
that also you can do. It's not a problem. You can do either way. And you have to find d square x by dt square, no? So if I different, so 2 will cancel. Okay. So an acceleration, no? So we have to differentiate. So if we differentiate again, it will become dx by dt square plus d square x by this is 1. So we find d square x by dt square, so that is equal to, so acceleration is 1 minus velocity square divided by x. And velocity is t by x. Check the answer.
It's a right answer.
Okay, so this is a simple way of doing it. You don't have to take square root now because differential become more complicated. So you have to differentiate both the sides of this two times, so it will become 2x dx by dt equal to 2t. This is clear, no?
Ah, yes, sir.
So 2 I'll cancel, and then I have to differentiate again with respect to time. So it will become like this. UV rule. Okay, so this is acceleration, right? This one, that is 1 minus velocity square divided by x, and velocity square from here, velocity from here is t by x.
Okay.
Okay, so next one, your particle starts to move from position x equal to 0, t equal to 0, along positive axis with v, this one, where alpha is a constant. This is for particle. Yes. This is also very simple. So we integrate it. So integral of x raised to the power half is x raised to the power 3 by 2 by 3 by 2. So on x raised to the power 3 by 2, I can, okay, so you have to get in terms of time.
Hmm.
Did you get the answer?
No, sir.
So v is alpha into x raised to the power half. This is correct, no? So vx,
Two dark color pen.
okay, dx by dt alpha into x raised to the power half. So x raised to the power minus half dx equal to alpha dt. So to integrate both the sides. So it's x raised to the power half by half equal to alpha into t plus integration constant. So at time t equal to 0, okay, basically you have to get in terms of t. Okay, he has given x equal to 0 at t equal to 0. So this integration constant is 0. So x, yeah, I think we got the answer. So x is of alpha t. So it is t square.
Yes, sir.
So option C.
Yes, sir.
Okay. So this is simple one only. Velocity is dx by dt. And next is it clear?
Yes, sir.
Okay. How much time will it take, will be taken for a 100-meter long train? Okay, this is also very simple. Only one simple catch is there. Can you solve it? See, 100-meter long train to cross a bridge of length. Okay, so this is a bridge, and this distance is 1 kilometer. So suppose this train is a point mass, okay, and its velocity is given as 45 kilometers per hour, right? So how much time will it take this point mass to travel this distance? Suppose I'm considering train as a point mass,
1.5.
1 kilometer divided by 45
Yes, sir.
kilometers per hour. So it will be 1 by 45 hours. So in terms of second, it will be 3600 by 45. Okay, this is for a point mass, not a train. So the only complication is for the train to cross. When it's about to cross, the train will be like this. Okay, the train is moving in this direction. So the train at some time will come like this, and still further time, the train will become like this. Okay, so this is the front end of the train. Okay, so the time to go from here to this position, that is 3600 by 45. Got it? I'm just
Yes, sir.
considering the front portion of the train. That's like a point mass. So for the front portion of the train, to travel from this point to this point will be 3600 plus 45. Plus some additional time is required for this back end of the train to cross this point. So this additional distance has to be traveled, which corresponds to the length of the train. Okay. Another way to understand is if I take the back of this train, it will travel this much additional distance. Okay, that is the length of it, so 100 meters plus 100 meter divided by 100
40
meters.
by into
100 meters 0.1 kilometer divided by 45. This will be in hours. So into 3600. So it's 3600 by 45 into 1 plus 0.1 by 45. So this is a sort of a correction, or you can say some, okay, in some sense it's a correction because of the length of the train. So 3000, this is 9 5s are 45, 9 4s are 36.
So why minus 1 by 35, sir?
No, not minus. 0.1.
Okay, okay.
0.1, 100 meters is 0.1 kilometer.
Okay.
So it's 80. It's 80 plus something. So without doing the calculation, you can just straight away take this one. Okay. So to do it properly, 45, it's approximately 1, no? Yeah. Yeah, approximately it is, the correction is 80 plus, the correction is 80 by 45.
Is a 88 only.
So this is approximately 0.08.
Okay.
So in the exam, you should not waste time in calculating because you get the idea it's 80 plus something, there is for only one option. So you should save time.
Okay.
Okay, always do the calculations in the end. Try to get the concepts clear.
Okay.
The particle reaches point B from A in 1 second along semicircular path. If it is what is the average velocity of the particle? This is also a simple question. If you know average velocity, no. So velocity average is displacement average divided by the time. So displacement average means initial displacement minus final displacement. So this is actually this is the displacement. Its diameter, so it's 2 meters in 1 second. Then okay,
But it's not in the option, sir.
1 second, 1 second for the radius 1. What is the average velocity of the particle? Average was the displacement. Sorry, it's not 2 meters. Ah. Ah. Maybe the question is wrong. Maybe if it is average speed, then it is pi d
3.1.
pi d by
Answer is
2.
1.
If it is
Output the
speed average, then is pi d by 2, and diameter is 2. So it is pi. So is the correct answer option A?
no, sir. Point B. Option B. That is IITB.
Okay, actually this question I have in my playlist. Uh, this is kinematics, right?
Yes, sir.
Correct option is option B, 2 meters per second.
Okay.
Okay, I have solved this problem. This is from Allen sheet. So, what is your the answer?
1 meter per second. Option D.
Okay, is 99. No.
Yes, sir.
So, okay, forget about the answers and all. So, this is the concept. Velocity
Okay.
average is the displacement. This is its diameter. It's the AB divided by 2 seconds. So, it's 2 over 2. So, it's 2 meters per second. So, this what I did first is correct one. Okay, a particle completes a semicircular path of radius with uniform speed v. What will the average acceleration? Semicircular path of radius r. This is also trivial only. See, whenever you see average between difference between average and instantaneous is what? See, instantaneous acceleration is dv by dt. Forget about the vector and all. Okay, I'll bring that later. Average acceleration means instead of d, we have to take delta v.
T2 minus V1. Yes, sir.
Okay, so delta v means final velocity and initial velocity. So this is a semicircular path, no? So it will move like this. Let's look at it. So initially the velocity will be like this, and the final velocity will be like this, and it's uniform. So speed is always like this. So it's v, only the direction is opposite. Okay, so the change in velocity is 2v, and the time duration is half path. So it's 2 pi r.
Pi r by V.
Pi r by v. There is the time, right? So it will be 2v square.
By
Check
pi r.
the option B.
Yes, sir.
Okay, so you always have to go to the start from the basic. Incidence acceleration is dv by dt. So only difference with the average is instead of dv, you have to take delta v. Delta means you don't have to bother what's happening in between. Just the final minus initial.
Yes, sir.
So shall we close now?
Yes, sir.
Okay. Uh, so important thing is you have to revise and you have to solve problems. So and what about your laptop? Will it come or not?
Yes, sir. Will be returned, but time.
No. So what is the problem? It's have they given it for repairing or still at home?
No.
Huh?
Is in the store, sir.
Okay. So it will come soon, right?
Um.
Yeah. Because for revising, either you have to look at the notes or you have to look at the videos. Looking at the videos will take time, or you have to skip the videos properly. Looking at the notes,
Yes,
you
sir.
have to put the you need a JNT this thing for the Windows machine. Okay, then see you tomorrow. So tomorrow you want me to do something uh, uh, or Newton laws of motion?
Circular motion. We didn't finish, sir.
Circular motion, uniform circular motion, you know, right?
Yes, sir.
Okay,
Speed will be
and
faster.
this thing,
In that, that is also
you
relative
you,
velocity.
you have this one, vertical circular motion. See, this is the Allen sheet I have. In this, because for JE, it will be a little bit different. This for NEET only. So what they are covered is uh, circular motion. Where is the circular motion? I don't see circular motion here. Projectile motion is there, horizontal projection is there, oblique projection from height. Okay, relative motion, commanding relative motion. So circular motion is there for NEET or not?
Yes, sir. Yeah.
Okay, maybe they are covered here itself. Okay.
Okay, no problem. You can cover it during that Newton's law of motion.
Okay, circular path is there. Circular track, semicircular track, circular motion is there. Okay, circular motion, vertical circular motion is there.
Yes, sir.
Okay. Okay, maybe I'll some short form problems in that vertical circular motion, horizontal circular motion.
Okay, sir.
Okay, and then should I move on to Newton laws of motion?
Yes, sir.
Because next one is Newton laws of motion and friction. Okay, then see you tomorrow.
Bye, sir.